We want to talk about rationalizing denominators. So here is a little question to think about. We have two numbers, 6 over square root of 3 and 2 root 3. Are these numbers equal or not equal? Well, one way to answer the question would be to use a calculator to get a better understanding of these numbers. The first number is 6 divided by square root of 3, and that comes out to be about 3.46. The second number is 2 square root of 3, and it seems that the two numbers are equal to each other. But the problem here is that these are approximate values, 3.464101615, and after that you don't know what would come. These are approximate values and you don't know what would come next. 1 could come next for the first number and 2 could come next for the second number. In that case, you can't say the two numbers are exactly equal to each other. They're only similar numbers. So how do we tell if they are equal or not? The way to figure it out is to use this method called rationalizing the denominator. So what we are going to do is to multiply the first number by this number 1 in the form of square root of 3 over square root of 3. So multiplying any number by 1 is not going to change the number. So this is still 6 over square root of 3 in value. But if you do that, you see this is 6 square root of 3 over, now square root of 3 squared in the bottom, and that's 6 square root of 3 over 3. And now you can cancel a factor of 3 out, then that's going to leave 2 out of 6, and that is 2 square root of 3. So now we see definitely we have 6 over square root of 3 equal to 2 square root of 3. So this process is called rationalizing the denominator. In this expression, 6 over square root of 3, the denominator has a radical expression. And after following the steps here, after the computation, we got rid of that radical expression from the denominator. Okay, here we have the second example. We want to rationalize this number. So the trick is to multiply the number by 1 in the form of a fraction with the top and bottom the same number as the radical expression in the denominator, or the original expression. So if you do that, if you multiply two numbers in the denominator, it gets rid of the radical sign and gives you 10. In the numerator, we have 4 square root of 3 times square root of 10, and we can combine these two radical expressions and write it as 4 times 1 square root radical sign, and under that sign we have 3 times 10, and that is square root of 30. We cannot simplify square root of 30 because 30 is 2 times 3 times 5, and there is no squared factor. Now finally, we see between 4 and 10 there is a factor of 2. If you cancel out the factor of 2, we get 2 over 5 together with the radical 30. So here is the final answer, 2 square root of 30 over 5. So the next example, in this example, we're going to use another trick. So in order to rationalize the denominator, what you're going to do is multiply the number by 1 in the form of, look at this, square root of 5 minus 1, square root of 5 minus 1. Just change the sign in the middle here. Change plus to minus. So that's the trick. Change sign. And what happens? What happens is that we multiply numerators 8 times square root of 5 minus 1, and we multiply the denominators. Plus 1 times minus 1. Okay, now if you simplify the denominator, let's scroll down a little bit. So let's work it out here. So we're going to FOIL this out. So multiply these 4. So the first one is square root of 5 times square root of 5. That's square root of 5 squared. The second, we have root 5 times negative 1. That's negative root 5. And 1 times root 5 is plus root 5. And 1 times negative 1 is negative 1. So then if you take square of a radical, that the radical sign goes away. And that gives you 5. And the two middle terms, they are plus minus same number, so they cancel out. So we are left with minus 1 here. So 5 minus 1 equals 4. There is no more radical sign now. So the denominator is 4. In the numerator we have 8 times square root of 5 minus 1. And if you cancel 4 out, the answer is 2 times parentheses square root of 5 minus 1. Okay, here is the last example. The idea is the same. We multiply top and bottom by the denominator after changing the sign in the middle. So x over square root of x minus square root of y. We multiply this by square root of x plus square root of y, square root of x plus square root of y. And then we simplify this expression. So on top we have this. In the denominator we have square root of x minus square root of y times square root of x plus square root of y. For this out, we have square root of x squared, square root of x times square root of y, minus square root of y square root of x, and then finally minus square root of y squared. And this is x, and two middle terms are removed, and minus y. So x minus y in the denominator. So we have the answer.